Setting up the pyrolysis unit near Novokuznetsk at a coal mine. Here's how it looks. First day of setup, equipment arranged. The KHGs are already here, waiting their turn. End of day one. Interesting machinery we've got running here on day one. Putting everything in its place, assembling the scrubber with the flue, all in bright gray. The reducer is on the loader. Guys are cladding the workshop. Time to install intermediate heat exchanger, slowly covering the roof. It's our second day. Day two, things are busy. The loader is in place. Assembly work's almost done. Heat workshop here. Plan for expanding the second setup. Place the loading device in relation to reactor rotation axis. Mounted burners, cables, and trays. We have an external flue, final prep for first equipment launch, currently pressure testing, checking for leaks. This piece weighs about 20 kilos. We've moved everything. All right, that's it for us. It's happening. First machine startup. We've been waiting. We're tired, but we're pushing through. It's the time when we might see some unexpected issues, but we're on it. We're in the pyrolysis phase, so crucial time, but we're ready. Last preparation before starting setting up the burners. We can only adjust them during pyrolysis. Because there's no gas to take right now. best of the best. Everything has to be perfect. It's our first time. The first pyrolysis cycle at our Novokosnetsk facility. Crucial moment. We're checking everything, multiple times on the computer. Everything is being displayed. Night is falling, waiting for the gas to come out. Here's the gas burner. It's assembled. We'll be setting it up here, adjusting it, then it goes back to the furnace. The gas burner set up before, they're adjusted now. Gas. These are our parameters. 40% gas, scorching off, moving on. Running on 2 gas burners on 1 step. About 10 kilopascals of pressure in the system. Peak time now. It's our first test pyrolysis in Novokosnetsk. Using a 30 cubic meter unit, loaded 3.8 tons of KGS chips. These are large tires, roughly. $20 kg each. We're halfway through the cycle now. The paint's still burning off. A bit smoky here. Outside it's minus 32 degrees. Поэтому do we want warmer with smoke, or do we want cold? Our first pyrolysis cycle is wrapping up. It's 3:30. We started at 9:30 p.m. This red line shows reaction speed. It's dropping quickly. We've already hit the gas. Blue, that's gas burners. We need more for drying the residue, so this is how we do it. We also have 2 more liquid burners. What else do we have on the panel? Red's gas activity being vented to the flare burner. Blues. Here you can see gas burners being switched on and off. Yellow, that's liquid burners. They were not active throughout the cycle, but they started at the end. They're being connected for drying the residue. Interesting point, the reactor's fully heated now. I'm telling you, no need for the engineers to calculate thermal expansion. I got this. In general, it's almost a tie, but I'm capturing the last moments of the pyrolysis cycle. Gas pressure is really low. Reaction dipped for a week. I'm adding a bit of liquid burner. Now the burner is at 3 kPa. It'll switch off by itself. I'll do it first. Now we have to pick something else. We have a cool down timer. Select 50 degrees and press enter. Our menu is updated. Probably need to stop the reactor rotation. My attempt didn't work. Turned on the timer. The electrician logged in remotely. There are 148 minutes left. Either 50 degrees or after 150 minutes machine will turn off. Coolant goes through this door to the reactor burner and cold air is sucked in. We open the doors outside, the cold air comes in, passes through the skin, going into the chimneys, then goes to the smoke sucker. The air heats up to over 200 degrees. Temperature drops to 200, a really effective coolant. The temperature change is more than 200 degrees. We're prepared for the first soot discharge during the startup process.
Переплата.
2021, February 13th. DIM started up. That's right. Let's go.
You did everything right. Get it going. Need anything? I haven't tried it. Go ahead if you think so.
With the right, I agree. Is it without inserts? Do we have big bags? Yes, it rotated the other way before. No, the other side. Vyacheslav is looking. The blades have been updated on this device. We'll try to unload faster than usual, at least with a larger device.
На данной установке выполнены модернизированные.
Hoping that the unloading speed won't take more time than a smaller device. One burner misbehaved, so the stoker is handling it now to make it work properly. We're planning to process chips again today. High density, this small pile is almost 4 tons. A hatch at 1.200 with flip bolts. When there wasn't more to devise for this device, we made such things. So that workers don't lose the nut hits here and gets fixed. If we need to change nuts, there are keys here. This is the kind of stuff we come up with when we're not too busy. Started pouring technical carbon after pyrolysis. The guys haven't bought polyethylene inserts yet. Polyethylene liners makes the soot very fine. Might even seep through the big bag to keep everything clean. It's advisable to use a polyethylene liner. Here it's handled by one person. During the procedure, he's only engaged about 10% of the time, so he can do other stuff. During unloading, our night guard does it, simply takes hold of the pallet and moves it. To the side, a new loaded bag is placed. It's secured, simply it's tied with a rubber band. It's temporary, they'll just put a regular automotive tie down. It's a slow process though. It's pretty cool. We think it's the best technical solution in the world, because no screw feeders are used, there is no friction pair. So there's no friction pair, nothing can jam, it empties by principle. Like a concrete mixer, we check the state of reactor after pyrolysis. All good. We unclip the fill big bag. Everything is even right across the burner zone. The mouth is clean. Only at the start, right? We just checked with a rod. First time like this. A small amount. Fell into the mouth. Had to pull out the chips. They don't twist so well. It's clean in the reactor after unloading the soot. First on the bag and then on the second one. It was... Now we'll be pulling out the metal cord. Actually, you can see, I still think, if it's now half loaded, it might be full. We reattach to the metal. Go back. Chip metal from tight bundle is not achievable. Drop my hammer again. And I had to rebuild it. Well, the hook is to blame here. It needs the... Throw it farther, very fine chip. It's a grind when unloading metal cord. Doesn't want to tangle at all. We have this canister. Forklift inserts its arms. Pulls it out and hauls it outside for further tipping. Now we have this larger chip. Chip brought. Here it is against my hand. Around 90% twist, like that. It's tiny, approximately 20 by 45 cm. It doesn't want it. Better to change the cutter step for tire cutting to get bigger pieces. But we didn't think about it. It was just a test. Took the first video we came across and ran it again. We started at 1818, now it's 1843, and the steam from the reactor is 64 degrees. The smoke from the reactor is 265 degrees. We'll see when we'll start working on the gas burners. Right now, 3 liquid fuel burners are working full blast. We're conducting the second. An hour since the start. The steam temperature from the reactor is 162 degrees. Reaction speed is around 114 to 130. And we'll have pyrolytic gas. So this is interesting. The reaction started to curve upward. Before this it was straight, which means the reaction wasn't happening. This upswing means the water is boiling, roughly between 1836 and 1850. It's clear that there's no pressure, no steam or gases formed, straight pressure line, and then started to curve upward. It'll fully go up soon. We'll need to reduce the burner power to output. The flare burner is open and the reaction speed is increasing. Pressure is growing. The flare burner is 10% open and the reaction speed is powerful. We're waiting for enough gas to start the gas from the previous graph. Pyrolysis always happens the same way. Lack of info makes pyrolysis vary. Just like boiling water, a straight line. Everything's going upward. This was the previous cycle. Now we're on the second one. Should see the same as I tried to switch to gas burners. We've active pressure growth. Lowering the power of liquid burners, for those who don't know how the transition works, it's gradual. We reduce the power of some burners and increase the other ones. 30 seconds passed. I already turned off 2 liquid burners and put gas on the second one. Turn to the pen. Now I've turned on another gas one. We have a drop in pressure. Need to turn off the flare burner. It's on manual mode. The automaton is tracking all my actions to write a program for automatic system control. The time is shown at the bottom right. You can track how often I turn on the camera. I turned on the gas burners and we're going steady with them. The flare is now 20% open. These 3 lines are aligning. This is what we're waiting for. Everything in the room looks like this. The paint is already... all burnt up. It doesn't smoke anymore. This bunch of metal oil. You can see it while it's barely twisted. The metal lord bundle barely twisted, right? We've got standard bearings here. You can change them anytime. No special tools needed. You can replace bearings and such. Everything's done knee deep. That's why the lower chart is interesting. This yellow line shows liquid fuel burners working. See the reaction growth here? We've just turned it off. See the steps? We've switched from liquid to gas burners. Turned off liquid, switched on gas one. Here I merely switched from one gas stage to another. Now gas burners are under, so they're off. All of this is recorded through the year, fully documented. It's around 10 p.m. Exhaust gas temperature is just under 400 degrees. We're steady around this ceiling. Presently it's about 11:30. The process peak will end, reaction speed will drop. Then we'll start calcinating residues, raising the temperature. Nearly half an hour left. We are moving. along smoothly. Everything's running smoothly. We're sedately using 2 small gas burners. No need to crank up the temperature anymore. The gas temperature has slightly exceeded value. Last Saturday, we carried out the second pyrolysis cycle. Had to stop the process towards the very end due to a system hiccup. It resulted from insufficient cooling of the condensation line. A column of pyrolysis liquid formed within the pipes after collectors, obstructing gas flow. We found out that water from an underground tank was sucked in with air. The pump couldn't push through this, and there was no cooling. Upon encountering this issue, we stopped the entire process without reaching the second and third stages, meaning no gas was let out. The system was able to safely pass through all gases. There was a lot of condensate trapped in these pipes. Managed it manually to avoid taking harsher measures. Now we'll open the reactor to peek inside. We didn't quite finish the cycle, so the residues are not fully pyrolyzed. You can see carbon particles inside the metal core. Looks like just water. Looks like the process is done, but it actually needed another half hour in the reactor. So we decided to reload another batch of tires. While it might seem that only half an hour is required for everything to heat up, it actually takes another 6 hours. So we'll reloading the reactor. Our second cycle ended not so well due to air leaks into the cooling system. We fixed this issue and added new tires, since calcinating residues from the last cycle is not a good idea. So we decided to add more rubber and redo the cycle without unloading the previous batch. The unique part is the fuel is way better and light. For example, the heavy fractions we showed in previous videos showed it looks like cooked condensed milk, but here in the cold, like normal condensed milk. Uncooked, absolutely liquid, here it is, basically pointless. These are the light fractions. Their normal color, they go into the middle fractions, and the ground has some barrels totally. Not that specific smell from regular tires, large tires. They don't give that sharp smell. There's practically no smell. I'm standing right above the container and just turned on the third start. First stages, right after I turn on the second stage liquid burners, going full power now. I'll turn on the new chart. New chart starts from the beginning of work, so it just doesn't write anything blank. Well, we should wait for 2 hours, 10:40. So 12:40, waiting for the gas. This production has a great organizer, all right? Right? Does everything right, worries, cares, understands everything. Such a person will, of course, have everything running. Here we start with chip. Big chips. Go to pyrolysis. Smaller chips go further to the shredder into rubber crumb. So immediately. 2 products for sale. Chips, and here the pyrolysis starts. So 2 shops next to each other and get 2 products right away. Full recycling. Cycle. Large bell-aged tires, how it looks. Continuing the 3rd pyrolysis cycle. In Novokuznetsk this time. Reduce the burner power to 1 stage. Flare works at only 20%. So in. This time we're in the green zone. Last time we were in the yellow zone. The green path is longer. Yellow is shorter, but riskier. Reds. Most dangerous. This time decided to go slowly. Process takes about an hour longer, but for beginners, it's perfect. The extractions aren't installed yet, so you can see no smoke at all. And here, too, chips are being prepared. The 3rd day of the process. You can see it's coming to an end, because the peak of the process has passed, and you can see a slight. Start of the curve bending downwards. Starting to land, gradually entering a dry residue calcination mode. Everything's smoke free here. The paint from the first cycle got burnt. Everyone's peaceful. Oh, this guy ahead isn't even bothered. You can tell he's just playing on his phone. We're opening the gate because it's too hot. Shop. The shop is insulated but unheated. Take to S6 to Teplioni. I free itum neotaplevemi.
It's got a 7.5-ton effort and comes with a service platform. There's a canister for unloading metal cord. The pusher is for unloading the metal cord. It also comes with brand burners and cables. Racks are not included, but we provide drawings for them under our guidance. It includes an operator's cabin with all the automation inside and so on. A 20-foot condensation container is also included. All pumps, fuel, water, and heavy fraction pumps with an intermediate heat exchanger. A tank for fuel sediment isn't included, but we provide it. Drawings, scrubber for flue gas cleaning, aka wet cleaning with lime water. The chimney pipe isn't included, so all of the entire equipment fits in one truck. It was designed with that parameter in mind. Everything is carefully arranged. The current price needs to be clarified as we constantly improve the design. There may be cheaper options without automation. Pyrolysis process is about 9 hours. Loading is right there. maximum loading capacity. Cooling is approximately 5 to 6 hours. Then the carbon residue is unloaded. That is through. That opening, big bag is placed underneath. According to the procedure, this takes 2 hours. Unloading the metal cord, then next. Step is going into this canister. According to the procedure, it's 30 minutes, including removing the lid and loading raw material. So for example, for KGS chips, it's just half an hour. To load cargo tires, it's about 2 hours in total, so once a day a full. Pyrolysis process is performed. Such an installation, the installation is cooling down. The third day cycle is done, all went well. Okay, in cooling mode, meaning that the operator sets. The time or temperature to cool it down, the reactor rotates automatically. Smoke sucker is working. Once the required parameter is achieved, everything will stop in case if the reduction gears are jamming or something else. If the gears are jamming, we have an automatic stop. As the frequency converter will see a surge. This is how soot unloading looks like. It's the fourth day, planning on doing the fourth cycle, so we are unloading after yesterday. The pall underneath for unloading was attached. The reactor rotation was begun. Big bags are without polyethylene liner. It immediately starts to fill it up. We loaded Bellis-type large dimension tires during the trial. Known as KGS, there are noticeable differences in the quality of the obtained fuel. Right now it's hard to say exactly how many tires were loaded, as no weighing was made, but for cargo and passenger tires, it's 440 liters of fuel per ton, 350 kg of carbon residue, 120 kg of metal cord. For now, we can only talk about the proportions. To the right, to the left. These are our averages. Fractions, light fractions, and heavy fractions. So we got 550 cube of middle fractions, 200 liters of light fraction. Got 200 L of heavy fractions, ended up 60 L. You can calculate the ratio. Unlike truck tires, heavy fractions from Keisha remain liquid, oily like condensed milk, even from truck tires. They just harden like bitumen. Well, should we try and light them? Asphaltene, mazout, you know. Here we dip, then just extinguish, bright, light up slowly, burn steadily. Now light is like gasoline, but it's there. Let's go to that corner. It ignites instantly. I'll add, large tires are made from better quality materials. So, no plasticizers. Use natural rubber. Because of this, heavy fractions remain liquid. These are medium fractions. They should burn slower, again for the fourth time. After the fourth start, we unload the metal ore. I think after watching it 10 times, it's boring. Our testing of the installation in Novokuznetsk is ending. Today's the fourth cycle. It's nearing the end peak of the process. You can see how we've learned to plan the pyrolysis graph. It's good because everything goes calmly and predictably. welding over. There. Our guy didn't have a chair. He decided to weld one. Everybody's calm. Time to weld a chair. I'm exhausted from this race against time. It's practically the end of the successful final testing cycle. During the startup works, the 5th cycle I will be tracking remotely, so that the guys can work independently without me, but I'll give instructions if anything goes wrong. The guys are used to the installation. They're calm about the pyrolysis, everything's going smoothly. Today's February 16th or 17th anyway. It's Wednesday, everything... moving. The construction is fine-tuned. What else to add? How many videos to record to prove the efficiency of drum installation?